Example number 3, and I read again. A flat sheet of cardboard has a length of 32 centimeters and a breadth of 20 centimeters. 4 identical squares, each with side x centimeters, are cut out of the 4 corners. The sides are folded up to form a box in the form of a right prism. A. Determine the value of values for which the volume will be a maximum. Part B. State the dimensions of the box. Part C. What is the maximum volume? So let's attend to part A. Here is our rectangular box, cardboard box, which we are going to cut a square on each corner. That is removed. All that I've indicated is being removed. Then we can formulate an open rectangular prism. Remember, they said the length is 32. So if we remove x here and x here, then this is 32 minus 2x. The same applies to the breadth. If we remove x here and x here, we remain with 20 minus 2x. So those are the dimensions of our box. That is the length and the breadth. But the height will be x. Please notice that. So I am having here length 32 minus 2x, the width 20 minus 2x, and our h is equal to x. And the question is talking about determine the value of values for which the volume will be a maximum. So when we are talking volume, it's length times breadth times height, which then gives us that. But whenever we are talking about maximizing or minimizing, we find the first derivative. So deriving this statement, we get what we have here. And remember, even when we're doing functions of cubic graphs, we noted that when we differentiate, we always equated that to 0. So this has not changed. When you differentiate your v, you equate to 0, whatever you get. Then you solve. But be careful in this question, because when you are having 20 minus 2x, it should be greater 0, because it's a side. It can't be negative. So at the end, x is less than 10. That's what it is saying. This is more than 10, because this is 1, 3, 333. So it's more than 10. Ours must be less than 10. Therefore, our x is only a 4. Part B was saying, state the dimensions of the box. Now we are just stating the dimensions of that box. So that box should have 24, which is a result of substituting our 4 here. 32 minus 8, we get 24. You substitute your 4 there. 20 minus 8, you get your 12, and your height is x. So these are the dimensions of that box. Part C is saying, what is the maximum volume? Now we are talking of the maximum volume. So the maximum volume will be given by the original statement for the volume. We are substituting a 4 wherever there is an x, and we end up with 1152 cubic centimeters. Or we actually calculate the length by substituting our x. It will be 24 times 12 times 4, which is exactly the same. Now we are doing the last question for today. Recall the following formulae. I'm just calling you to recall from your vocabulary the following formulae that we have met in our grade 11. A, which is the area of a circle, it's pi r squared. The circumference is pi 2 pi r, and the volume of a cylinder is pi r squared h. The total surface area of a cylinder is pi r squared plus 2 pi r h. So the question goes, a cylindrical right prism has a radius of r centimeters and a height of h centimeters. the dimensions are limited in such a way that the sum of the circumference of its base and its height is always equal to 21. When we are having questions, it says, show that the volume of the cylinder is given by V is equal to 21 pi r squared minus 2 pi squared r cubed. Part B, determine r in terms of pi if the volume is a maximum. C, determine the maximum volume. D, if the volume is 109,18, determine the dimensions for which the total surface area of the cylinder would be a minimum. So part A, we are told that the circumference plus the height is always 21, which enables us to find our h in terms of r and pi. So the volume by definition is pi r squared h. Our h, we have written it there, is 21 minus 2 pi r. Then when you do that, this is exactly what we are required to show, that it is 21 pi r squared minus 2 pi squared r cubed, which is what we got. And part B reads, determine r in terms of pi if the volume is a maximum. So to maximize, we differentiate and equate to 0. So we end up with that. This will give us equal to 0, so r is 0. R cannot be 0 because there is nothing. There is no radius. But then we choose this one, which gives us 21 minus 3 pi r, so our r is 7 over pi. That is our r, to make sure that we maximize on the volume. It must be 7 over pi. Part C, determine the maximum volume. As I have already showed you in previous examples, we go back to the volume which we calculated, and in this case it's also given. So we substitute our r, and then we will end up with 343 over pi, which reduces to 109,18 cubic centimeters. Part D, if the volume is 109,18, determine the dimensions for which the total surface area of the cylinder would be a minimum. So we are talking total surface area. So total surface area will be equal to that. According to the formula that I said, this we need to remember or recall. So our H will be that because the volume is known. So we go to the surface area, which is that, but our H, we now substitute our H, which we calculated above, and then this gives us that. This gives us that. We then differentiate our total surface area. We get 4 pi r minus 218,36 r to the power minus 1. Once you differentiate, equate to 0. Solve for r. Our r is equal to 2,59 centimeters. So our h therefore will be 109,18 over pi times 2,59 squared, which then shows us that our h is equal to 5,18 centimeters. Classwork, exercise 13, numbers 1, 2, and 10. I thank you.